Okay, so now we're going to solve this problem. It's again about non-concurrent forces, but this time the forces are not parallel. Right? So we have a roller here, so we're going to have one force. Here we have a pin. Okay, so we're going to have a force there and a force in the x direction. Okay, so this one will be R A Y R B Y and R B X. Okay, so we have the same tricks again that we've been able to use all along. Right? We'll do sum of the forces. X is equal to 0, which is equal to, I have RBX going in a negative direction, negative RBX, and then I also have the X component of this 1,000 pounds, so minus 1,000 pounds times the cosine of 65. Alright, so from that equation we can solve RBX. Okay, and we get 0 equals negative RBX minus, and 1,000 times cosine 65 is 422.6 pounds. Alright, so when I rearrange this, RBX is equal to negative 422.6 pounds. Okay, it's negative. What does that tell me? I drew this RBX backwards. Now I knew I was because I wanted you to see what happens when I do that. I have drawn it backwards, so I just get a negative number. Now, because my equations depend on the way I've drawn that, if I've used this anywhere else, I just have to substitute that negative number in. Okay, so let's think about it that way. Alright, so we'll just leave it. What we know is RBX is actually 422.6 pounds in the other direction. Okay, alright, so let's do sum of the moments. We need to do it at one of the connections. I think it's easier probably to do it at the pin connection B. Alright, we also are going to have to write the sum of the forces Y at some point, so we can do that as well. Alright, the sum of the forces in the Y direction is equal to 0, which is, if we start here and just move across, we have RAY in a positive direction minus 3,000 pounds, okay, minus, we're doing sum of the forces Y, so we want the Y component of this, 1,000 pounds times sine 65 degrees, okay, plus RBY. Okay, so now I have one equation, two unknowns, not particularly helpful. Alright, so we'll do sum of the moments. Let's do it at B, at the pin connection, because I get rid of two terms there, two forces. Again, counterclockwise is going to be a positive moment. And so let's start here with RAY and move across. Right, at RAY, it pushes up this way. We're pinned here at B. That's going to tend to be clockwise, so it's negative. Negative RAY times 20, 40, 60, 80. 80 feet. Okay. Let's get rid of that little boo-boo there. Go back to typing over here. Okay, times 80 feet. Alright? And the next one is going to be the 3,000 here. We're pinned there. That's going to tend to be counterclockwise, so it's a positive moment. And it's multiplied by 40 feet. Alright? Now we have the 1,000-pound force up in the corner, and there are going to be two moments associated with it because of its two individual components. So we have a y component of that force and an x component. Alright? And the x component is just 1,000 pounds times cosine 65. And the y is just 1,000 pounds times sine 65. Alright? But they have different perpendicular distances to point B. Alright? To move the y component to be in the line of action of B, we have to move it from here, from this line of action, to here, this line of action. So what's its perpendicular distance? 20 feet, right? So let's put that in. And that's also going to tend to be a positive moment. 20 feet times 1,000 pounds sine 65. Okay? And then the next one is going to be the x component. Okay? And to bring it from here to here into the same line of action, we have to move it 15 feet. Excuse me. Also going to be counterclockwise rotation. So we do plus 15 feet times 1,000 pounds cosine 65. Okay? So now that you have that worked out, we can combine some terms. That whole thing's equal to 0, alright? And we can solve this equation for RAY. I'm going to plug some things in my calculator. Give me just 1 second. So after a little crunching here, we see that we have 0 is equal to negative R AY times 80 feet plus 144,465.4 pound foot. So RAY is equal to 1,806 pounds. Alright, now I can plug that back into my equation, sum of the forces y, and get 0 is equal to 1,806 minus 3,000 minus 1,000 sine 65 plus RBY. So again, plug it into my calculator. I get negative 2,100 plus RBY. So RBY is equal to 2,100 pounds. All right.